Imagine a land at the very bottom of our world, Antarctica. It's a place of extremes, a vast frozen wilderness that stretches farther than most people can truly comprehend. For half the year, this immense continent is plunged into darkness, the sun vanishing below the horizon for months on end. The world here is wrapped in a long, polar night. This is the great Antarctic winter, a time of unimaginable cold and profound silence. The wind howls across the ice and the temperature drops lower than anywhere else on Earth. The land and sea are locked in a thick, unyielding layer of ice, creating a world that seems to sleep, waiting patiently for the return of light and warmth. But beneath this apparent stillness, powerful forces are at work, shaping not just Antarctica but the entire planet's climate and oceans. Most penguins migrate north to escape the cold, but emperor penguins remain behind. They huddle together, braving the harshest conditions on Earth to raise their young, a testament to resilience and adaptation. Relentless katabatic winds, born in the high frozen interior, sweep down the slopes at over 200 miles per hour. These winds make Antarctica not only the coldest but also the windiest place on Earth, sculpting the snow into fantastic shapes. In this frozen darkness, scientists in isolated research stations endure months of cold and isolation. They gather vital data, measuring temperatures, tracking winds, and studying the ever-changing ice. They watch the sky for the shimmering southern lights, the aurora australis, and search for atmospheric clues. Every observation helps us understand the story of our changing planet. The Antarctic winter is not a period of inactivity. It's when sea ice expands to its maximum, covering millions of square kilometers. This ice reflects sunlight, helping to cool the Earth and regulate global temperatures. The atmosphere above the pole cools dramatically, setting powerful weather patterns in motion that ripple out across the globe, influencing climates far beyond the ice. This winter is a powerful engine, a fundamental part of Earth's climate system, driving ocean currents and atmospheric circulation. Understanding what happens here, in the darkest and coldest months, is key to understanding our future, no matter how far from the ice we live. The data collected here helps predict changes that will affect us all. Antarctica's winter sleep is not just a pause but a crucial chapter in the ongoing story of our planet, a story that connects us all, wherever we are. Antarctic winter cold is beyond imagination, an environment so harsh and unforgiving that it challenges the very limits of survival. The cold here is so intense it can freeze metal solid and shatter even the toughest tools, making every task a battle against the elements. On the polar plateau, temperatures routinely plunge below -70 degrees Celsius, making it the coldest place on Earth, colder than anywhere else humans have ever measured. Life barely endures in these conditions. Even the air itself sparkles with countless ice crystals, suspended and glittering in the frigid wind. Survival here demands special gear, bulky, insulated suits, face masks to warm each breath, and constant vigilance to avoid frostbite or worse. Exposed skin can freeze in mere seconds, and even vehicles must be kept running and heated to prevent their fuel from turning to gel and engines from seizing up. The record low, a staggering -89.2 degrees Celsius, was set at Vostok Station, far colder than any home freezer, and a temperature that can kill in minutes. Sometimes it gets so cold that carbon dioxide itself freezes out of the air, forming rare dry ice snow, an otherworldly phenomenon found nowhere else on Earth. This extreme cold is the result of months without sunlight, the high altitude of the plateau, and the vast reflective ice sheet that bounces away what little warmth there is. But the cold isn't just a curiosity, it's a powerful force that drives weather patterns across the entire southern hemisphere. Cold, heavy air spreads outward from the continent, creating fierce winds and influencing the movement of ocean currents thousands of kilometers away. The temperature difference between the frozen land and the relatively warmer ocean powers massive climate systems, shaping weather far beyond Antarctica itself. Antarctic winter cold is a relentless force, shaping not just the landscape, but the very climate of our world. It's a stark reminder of nature's raw, untamable power, a place where human technology is pushed to its limits. In this frozen heart of the planet, the engine of global weather never stops turning, silently shaping life on Earth from the bottom of the world. High above Antarctica, the polar vortex forms each winter, a vast, spinning mass of frigid air. This invisible cyclone isolates Antarctic air, locking in the cold. A strong vortex keeps the cold contained. If it weakens, icy air escapes, bringing cold snaps to distant lands. Inside, unique polar stratospheric clouds form, their icy crystals fueling chemical reactions. When sunlight returns, these reactions trigger ozone destruction, creating the infamous ozone hole. The vortex's health is directly tied to the ozone layer that shields us from harmful UV rays. Data from 2025 is crucial for tracking ozone recovery after decades of damage. The polar vortex is more than weather, it's a natural laboratory where the fate of our atmosphere is decided. Winter 2025 brought surprises, subtle shifts in temperature and sea ice. The Antarctic Peninsula saw slightly warmer temperatures, continuing a long-term trend. Meanwhile, the East Antarctic Plateau experienced record-challenging cold thanks to a strong, stable polar vortex. Sea ice recovery was mixed. Some regions rebounded, others lagged behind. Regional currents and winds played a powerful role in shaping the ice. Powerful katabatic winds battered the coast, pushing ice out to sea and creating open-water polynyas. These events highlight the continent's complex, ever-changing climate. Antarctica's winter is never predictable. It's a season of contrasts and discovery. Every year, scientists meticulously compare each Antarctic winter to those that came before, piecing together the evolving story of our planet's climate. These annual comparisons are crucial for understanding both subtle shifts and dramatic changes in the Antarctic environment. Sea ice, which was once considered relatively stable, experienced a dramatic drop before 2025. This year, there was only a partial and fragile recovery, raising concerns among researchers about the resilience of the region's ice cover. The Southern Ocean may have shifted to a new state, with less winter sea ice than in previous decades. This exposes more dark ocean water, which absorbs additional heat from the sun, further amplifying warming in the region. This feedback loop, where less ice leads to more heat absorption and even more ice loss, could accelerate both regional and global warming, making the situation increasingly urgent. In 2025, the polar vortex was notably strong and cold, a stark contrast to weaker years that saw early breakdowns and smaller ozone holes. The strength of the vortex can influence weather patterns far beyond Antarctica. While year-to-year variability is natural and expected, it's now happening against a backdrop of undeniable long-term change, making each year's data more significant than ever. The Antarctic Peninsula's persistent winter warmth is not a recent anomaly but part of a 50-year trend. This region is one of the fastest warming places on Earth, and its changes are a warning sign for the planet. Meanwhile, the deep interior remains bitterly cold. This doesn't contradict climate change, instead, it highlights how extremes and variability are increasing, with both record warmth and intense cold occurring side by side. The 2025 data, showing a warm peninsula and a frigid interior, perfectly illustrates the continent's complex and sometimes paradoxical response to a rapidly warming world. Antarctica's story is not simply one of steady warming, but of shifting weather patterns, new extremes, and unexpected changes that challenge our understanding. Each winter adds a vital chapter to our understanding, providing new clues and raising new questions about the future of the continent and the planet. The ice is telling us, change is underway, and its message is becoming clearer with every passing year. In the Antarctic winter darkness, the sky erupts with the aurora australis, the southern lights. Solar storms in 2025 made the auroras especially vivid, painting the sky with green, pink, and purple. These lights are born when solar particles collide with atmospheric gases, releasing energy as shimmering color. Scientists use magnetometers and spectrometers to study these displays, learning about space weather and atmospheric chemistry. The most common green comes from oxygen, reds and purples from nitrogen. For those wintering on the ice, the aurora is a psychological lifeline, a reminder of beauty and connection to the cosmos. The data and images from 2025 will inspire and inform for years to come. Even in the world's coldest darkness, the sky brings wonder and hope. Antarctica may seem distant, but its winter shapes the world. The vast ice reflects sunlight, cooling the planet. If it shrinks, global warming accelerates. As sea ice forms, it creates dense, salty water that sinks, driving the global ocean conveyor belt. This circulation supports marine life and regulates climate everywhere. Changes in Antarctic sea ice could disrupt these currents with global consequences. The ice sheet is a climate archive. Ice cores reveal Earth's history and help us predict the future. Antarctic weather influences jet streams and weather patterns across the southern hemisphere. The strength of the polar vortex and extent of sea ice helps steer storms and droughts far away. Every weather forecast is shaped in part by what happens in Antarctica's winter. This frozen world is the engine room of our climate. Its fate is tied to ours. The Antarctic winter of 2025 has been a season of discovery. Every data point, temperature, sea ice, auroras, reveals the interconnectedness of Earth's climate. Warmer peninsula, deep interior cold, patchy sea ice, all linked by shifting currents and winds. The partial sea ice rebound shows natural variability, but the lack of full recovery warns of lasting change. The system may be nearing a tipping point, shifting to a new, less icy state. Spectacular auroras remind us of our connection to the sun and the importance of understanding space weather. Most importantly, this knowledge comes from international collaboration, scientists from around the world, united by a common goal. The Antarctic Treaty is proof that we can work together for the planet's good. The lessons from the ice are scientific, and a call for global cooperation. After months of darkness, the Antarctic sun rises at last. The first light brings celebration and hope to those who endured the long night. The landscape transforms, ice crystals sparkle, plains glow with color, sunlight triggers a bloom of phytoplankton in the southern ocean, feeding krill, penguins, seals, and whales. The sleeping giant awakens, life returns. Sunlight also sparks ozone chemistry, and scientists begin monitoring the ozone hole's formation. The end of winter marks a new phase of discovery, building on data gathered in the dark months. We leave winter with a deeper appreciation for Antarctica's extremes and its global importance. The story of Antarctic winter is about the balance of our planet and our responsibility to protect it. As the sun returns, it illuminates not just the ice, but our shared future.